Hey everybody, your Friendly Math Tutor here with episode 5 of our SAT mini course. Each episode we're going to dissect a strategy or a topic that you can use for your upcoming SAT, which is really only a couple weeks away at this point. All right, so last episode we were talking about what we would do with literal equations and how we could avoid reading an entire paragraph and a diagram and have all these things that are there to kind of like mess with you and distract you from what you really need to do. And we ended with this closer problem, College Board Practice Test 6, Section 4, number 17. Instead of reading the whole thing, we are just going to get right into it. And this is exactly what you want to do when you take the test. So you come across this problem, you see an entire paragraph and a diagram and answer choices. And what you should do is just notice, just look really quickly at it and notice, oh, there's an equation. 2h plus d equals 25. Then go right for the answer choices. Look at the answer choices, and every answer choice is another equation that is solved for h. So that means all we need to do is take this equation and solve for h. We don't have to read about tread depth or riser height or have any understanding of this at this point. All we need to do is solve for h. So we can simply do that by subtracting d from both sides. So 2h is equal to 25 minus d. And then we have to divide each side by 2. And h is equal to 25 minus d over 2. And you might say, oh, hey, that answer's not there. But it actually is. So sometimes the way we solve things, they might have it in another form that's pretty much the exact same thing. We've got 25 minus d, so A and C are out because they have 25 plus d. B and D, though, have 25 minus d. And what they have is a 1/2 in front. And a 1/2 is the same thing, or multiplying by a half is the same thing as dividing by 2. So it is answer B because D has a negative 1/2 and we don't have a negative, we didn't divide by a negative 2. All right, so the answer ends up being B. All right, on to episode 5's topic of linear systems. So basically, when you do the SAT, this is a specific topic that shows up a lot, all right? So a linear system is when you're going to have two equations with two unknowns. They're typically going to just be x and y. They could be other variables, but on all the problems that I've seen on the SAT, there's going to be x and y. It's going to be pretty easy to tell. If you look at the opener problem, which we'll get to, you're just going to see two equations and an x and a y and an x and a y in each equation. That's going to tell you that it's a linear system. There are three basic types of problems that the SAT is going to ask in regards to linear systems. The first one is you're just going to see a typical linear system, and it's going to ask you for either x or y or x comma y, the coordinate pair that solves both. In those, you're just going to follow the school way. Typically, you'll just use the elimination method, both of which we'll go through. All right, we're not going to see an example of that type of problem, but I will on every problem explain the school way. But the two types that we're going to focus on, the school way is a bit longer. And in those cases, so the second type of problem is going to be one more like our opener, which is going to give a constant. So there will be another letter in the problem. So let's remember, not all letters are variables. All right. In this case, the x and the y are variables because they are changing. And if we have another letter, for instance, in this example, we have an A. We call that a constant because once we figure out what A is, it wouldn't change through the rest of the problem. All right. So again, there's a big difference between a letter being a variable and a constant. So the second type of problem will be you'll have your x's and y's in a linear system, and then you'll have this other letter. It could be A, it could be B, it could be K, it could be anything, right? Just not x and y. And you'll have to find the value that gives you either no solution or infinite solutions. And we're going to talk about that. And the third type of problem is when you have a linear system, just has x's and y's in it, no constant, no letter as a constant. And those ones, what you're going to have to do is find some expression in terms of x and y, like what is 2x plus 3y, or what is x plus y. In that case, we're going to go over the school way, but we're going to avoid that because there is a much quicker way, right? So again, 3 types of problems. The first type is just what you'd be asked in school, and you'll do the school way. That will be most likely the quickest, or you could plug in your answer choices, and that goes back to episode 1, all right? So if you haven't seen that, go back and watch that episode and see about plugging in answer choices. So on those types of problems, I would say either just solve it the school way or plug in your answer choices, and, depending on the problem, one way could be quicker than the other. It just depends on you individually. All right. So now to today's actual lesson on our opener problem. So this one is from College Board Practice Test 10, Section 3, number 15. It gives us a linear system, negative 3x plus y equals 6, and ax plus 2y equals 4. In the system of equations above, a is a constant. For which of the following values of a does the system have no solution? So what's going to happen if you look at it from the perspective of the school way, which is going to be the elimination method? What you want to do is, in order for it to have no solution, what you're going to end up with is 2 equations that look exactly alike on the left side. So this is in what we call standard form, where the x and the y are on the same side. Those 2 sides are going to look exactly the same, but the other side is going to be a different number. And then it's going to be like, well, if the left sides are the same and the right side is different, then there's no way that could ever happen. There's no x and y value that will solve that, and it'll therefore have no solution. So our goal is to kind of make that happen, all right? So this is more of the school way to solve this problem. So I have negative 3x plus y equals 6, and ax plus 2y equals 4. And what I want to do is, we want to make the coefficients the same, but you can't do it for the x's because we don't know what a is. So you want to do that for the y. So we want these to be exactly the same. In the elimination method, sometimes you may have learned in school how you want them to be opposites. But they can either be the same and you subtract them, or they can be opposites and you add them. But in this case, we're not even going to be going that far, so it's much easier to look at it as you want them to be exactly the same. And it'll make sense when I do this now. So what I'm going to do is multiply the top equation by 2. So I'm going to get negative 6x plus 2y equals 12. And then I'm going to recopy the second equation because I'm not going to do anything to that. All right. So in order for this, so notice, if the left sides are exactly the same but the right sides are different, that'll create this scenario where there are no solutions. And so what we need to do is pick the value of a that'll make that happen. Well, what's going to make that happen is simply if we made a equal to negative 6. If we did that, if a was negative 6, the left sides would be exactly the same, negative 6x plus 2y. In one case, it would equal 12. In the other case, it would equal 4. Well, that's impossible. That would create a no solution situation. So a must equal negative 6 in order for us to have no solution, which is answer choice A. All right? That is the school way approach, again, kind of using the elimination method in order to figure out what A would equal. Okay? So now let's take a look at the Your Friendly Math Tutor way. And again, it's just a little bit easier, I believe, but you may think that what we just did was the better way to do it. So it's going to be up to you to decide. Before we get to the Your Friendly Math Tutor way, so we're going to pause this for just 1 second. I need to show you something that you'll have to be able to do in order for the Your Friendly Math Tutor way to really have any chance of being quicker. And if you can do this, then it's going to make this way a lot easier. So I'm going to make up a different problem, a linear equation that's in standard form. Let's say 2x plus 7y equals 14. If I want to know the slope of this, all right, the longer way to do it would be to rearrange it to get it into slope-intercept form. So I would subtract 2x, and I would get 7y equals negative 2x plus 14, and then I would divide everything by 7, and y would equal negative 2/7 x plus 2, and my slope would be negative 2/7. All right, that takes quite a bit of time. So what I want you to try and do is practice being able to figure out the slope without rearranging. So mentally thinking of this 2x moving to the other side and becoming negative 2x, and then dividing by this 7. So what's going to happen is, if we look at this in standard form as ax plus by equals c, we mentally move the ax to the other side, and we're going to get a negative a. And then we divide by the b. So our slope is always going to be negative a over b. So if we look at this case, if I gave you 2x plus 7y equals 14, you should be able to then say right away that the slope is negative 2/7 without rearranging. If you need, and again, there's nothing wrong with this, if rearranging is easier for you and you need to see it written out like that every time, that's fine. For you, every time that I do the school way today, actually, scratch that. There's 2 later problems where the school way is going to be way slower, and we'll talk about that. But on these types, the no solution or their infinite solutions will give us the same result. On those types of problems, you may want to do it the school way. But if you're able to just do this pretty quickly, to just take a standard form problem and get the slope immediately, then your Friendly Math Tutor way is definitely going to be quicker, and I'm going to illustrate that right now. So what we have here in this way is negative 3x plus y equals 6, and ax plus 2y equals 4. So the other part of your Friendly Math Tutor way that's really important is you have to have an understanding of what a linear system of equations is. Well, it's a system, though there's more than one, so there's actually 2 in this one. It's linear, so if we graphed it, it would create 2 lines. And the solution that we're looking for is the intersection of those 2 lines. But if there is no solution, the only reason they'd have no solution, and anytime there's no solution, these types of problems, you could replace it with infinite solutions, and it'll give you the same answer. So what you need to do is think about, if there's no solution, the reason is because the 2 lines would be parallel. They would never intersect. And if they're parallel, they have the same slope. So the school way was looking at the elimination method. Your Friendly Math Tutor way looks at comparing their slopes. So we simply say, look at this first equation. What's the slope? Well, the slope of this one would be negative of negative 3, which is positive 3, over the coefficient of y, which is 1. And the slope of the second equation would be negative a over 2. If you're confused as to where I got that, go back a couple minutes in the video and take a look at how we rearranged these on the last example problem, and we figured out that the slope was negative a over b. All right, so negative 3 is 3, b is 1. In this case, negative a is negative a, and b is 2. Now, their slopes would be equal to each other, because there's no solution and the slopes must be parallel, or the same slope would create parallel lines. All right, and then it's really simple. It's just a simple cross multiplying. 2 times 3 is 6. 1 times negative a is negative a. Divide by negative 1. So negative 6 equals A. Same answer we got before. Again, there was a lot of explanation I had to do for this problem just to make sure that we understand these little shortcuts that we're taking. But the reality is you could go right to this and get your answer pretty quickly. But again, if you have to actually write and rearrange this, then the school way would probably be better for you. You'd be able to get -6 a little easier. All right. All right, now on to our second problem. So this one we should be able to go through a little more quickly, but I want to illustrate the school way and then your Friendly Math Tutor way. So this is College Board Practice Test 3, Section 3, Number 9. Kx minus 3y equals 4, and 4x minus 5y equals 7. Same as last problem, and the system of equations above. K is a constant, x and y are variables. For what value of k will the system of equations have no solution? All right. So we set it up. We take a look at how we would do this using the school way, which is really just the elimination method. And what we want to do is we want to make the left side look exactly the same so that we could subtract them if we were going to continue the elimination method. But since there's going to be no solution, we're just going to kind of stop halfway through and figure out what would make the most sense to make k equal to. So what I want to do is I want to look at the y's, and I want to make them exactly the same. Well, 3 doesn't go into 5, so I've got to multiply both equations. I'm going to multiply the first equation by 5 and the second equation by 3. That is going to give me a -15 for both of them. So I end up with this equation, 5kx minus 15y equals 20. And then 12x minus 15y equals 21. And then I want to just stop there and now analyze the problem. Well, what we said before, if there's no solution, then what we want to get is the exact same thing on the left side and different things on the right side. Well, the right side's just going to work out for us. Honestly, if the right sides were the same, it would just be an infinite solutions problem, and they would have infinite solutions here. So that's not really much that you even need to think about. You should be more focused on the left side. And what I need is for them to be exactly the same. So I need the coefficients of x to be the same. Well, the coefficient of x in the first problem the first equation is 5k, and the coefficient of x in the second equation is 12. Well, I need them to be equal in order for this system to have no solutions. And that will result in, if I divide by 5, that'll result in k equal to 12 over 5, which is letter A. All right, so now on to the Your Friendly Math Tutor Way version of this problem. So let's remember the basis of the Your Friendly Math Tutor Way is two things. It is you being able to find the slope of these two equations that are in standard form, to do that without rearranging it, just to be able to do it kind of immediately. And the other notion is that if there's no solution, then the two lines must be parallel. So those slopes that you find must be equal to each other in order for that scenario to happen. All right. So we take a look at the first one, and remember the slope is in standard form. Again, just to recap, is -a over b. So a in this case is k. So I get negative k over b, which is -3. And then for the second one, I get -a, which is -4, over b, which is -5. And then I can they're equal to each other because they have same slopes, because they're parallel, because there's no solution. All right, so you need to follow all that little logic train. All right. So now we do cross multiplying. So the first cross product is positive 5k. Let's remember a negative times a negative is a positive, and I will get positive 12 for this cross product. Now I just need to figure out what k is. So I divide by 5, and I divide by 5, and I end up with 12 over 5. Would you look at that? Same answer as the school way, but depending on how you look at it or the steps that you take, you have to decide which way you like better, all right? So that is how we solve systems of equations that they ask you to find a constant such that there's either no solution or infinite solutions. All right, cool. All right, moving on to our third problem. So this is an example of our next type of linear systems problems that you'll see on the SAT. This type is just going to ask, it's going to give you two equations with two unknowns. Here, all they did was switch the letters up from x and y. And they ask you for the value of an expression. They don't ask you for, in this case, w or t individually. If they did, you would just do the school way. In this case, they're asking us for an expression, so there's a little bit more of a quicker way. And to illustrate that, I'm actually, for this problem, going to show you the school way to kind of illustrate how long it could take. And then we'll see that your Friendly Math Tutor way. So in this one, it just is College Board Practice Test 9, Section 4, number 17. It says if 2w plus 4t equals 14, so 2w plus 4t equals 14, and 4w plus 5t equals 25, what is the value of 2w plus 3t? So that's the key. They are asking us for an expression. So 2w plus 3t is an expression that we need to find the value of the whole thing together. So let's take a look at the school way for this. So what we would notice is you have a 2 and a 4 here, so eliminating the w's is going to be a little easier than because 4 doesn't go into 5. So let's multiply the first equation by 2. All right. Again, this can be done two different ways. I just choose to do it where I make them exactly the same and then I subtract. I'm only doing that to keep it consistent with how I solved the problems earlier. But as many of you know from in school, you could make them opposites and add. The idea is to eliminate one of the variables, hence the elimination method. All right. So 4w plus 8t equals 28. And then the second equation I'm not doing anything with, so it's 4w plus 5t equals 25. And then I'm simply going to subtract, so that makes the 4w's eliminate. 8t minus 5t is 3t, and 28 minus 25 is 3. And then I simply divide by 3, so t equals 1. I'm not finished because I need to know the value of w to evaluate this expression. And I can go back to either my original equations. I usually choose the one that's easier. I don't see one here that's just easier. They have all positives. So I'll just pick the first equation because it has smaller numbers. So that's 2w plus 4 times 1 equals 14. So that's 2w plus 4 equals 14. Subtract 4. 2w equals 10. Divide by 2. W equals 5. And then finally, we can actually answer this thing. 2w plus 3t is 2 times w, which is 5, plus 3 times t, which is 1. That's 10 plus 3, and we get 13. And C is our answer. Of course, as you're doing the school way, depending on how quickly you can do this, there's certainly shortcuts we can take, but I just wanted to show every step. But this can take some time. All right, so now let's take a look at the Your Friendly Math Tutor way. All right, so for this one, let's rewrite the system. So 2w plus 4t equals 14, and 4w plus 5t equals 25. All right, so the way that you're going to know that you should attempt Your Friendly Math Tutor way is when they give you a linear system and there are none of those constants as there was in the last type of problem, and those ones, they'll be related to no solution or infinite solution, and you'll follow what we did earlier in the video. If they ask you just for one of the variables, either w or t or some, like maybe them as a coordinate pair, in that case, you are going to just do it the school way. The way we just did it is going to be the easiest way. But for these specific types, they ask for the value of an expression in terms of both w and t. So there's this little like shortcut that we can take that's going to allow us to get 2w plus 3t without ever knowing w and t, because we really don't care. All we care about is getting 2w plus 3t and looking at that as a single entity rather than figuring out w, figuring out t, and plugging them in, because that takes some time. And what you're going to do is you're just going to add the equations together. Whatever equations they give you, you're just going to add them together. If that doesn't work the way that this one's going to work out nicely, then try subtracting. And if that doesn't work, then it means that this shortcut may not work for this problem, and then you have to resort to the school way. But in almost all the problems I've seen where they ask for an expression, there is a way to do this shortcut. And watch how easy this is. So I'm simply just going to add my equations together. It's a little weird. In school you were taught, well, don't add your equations together until they're opposites, or don't subtract your equations unless they're exactly the same, because you're trying to eliminate a variable. But in school, you're always trying to find the x and the y separately, and then think of that as a coordinate pair. In this problem, we're not. We're only trying to find 2w plus 3t. So when I add these equations together, I get 6w plus 9t equals 39. Well, that's not what I'm looking for, right? But it's pretty close. Notice 6w is 3 times 2w. And 9t is 3 times 3t. So what if I were to just divide all these by 3? Well, would you look at that? I get 2w plus 3t equals 13. Done. 2w plus 3t is what they're asking us for, and the answer is 13. We get it without ever knowing w and t, right? So we don't need to know that. The whole point of almost these videos, besides understanding the concepts and be able to make these decisions on which way is quicker, is our goal. Our goal here is to just find the answer. It is not to do all these little steps in between that we normally just do in school, because that's what's expected there. There, it's a great place to do that. But here, it's better to just know these little shortcuts and get right to the answer. All right, so let's take a look at one more of these. All right, now to our fourth problem. College Board Practice Test 10, Section 3, number 19. We have the system 2x plus 3y equals 1200, and 3x plus 2y equals 1300. And based on the system of equations above, what is the value of 5x plus 5y? Oh, wait, Mr. Hale, you forgot the solutions, or the answer choices. Well, no, I didn't. Here we go. Here's our first grid-in problem from the SAT. So there's these questions at the end of each section that we call grid-ins, or they're really just open-ended. And they don't have answer choices. A lot of what we've talked about so far, and because most of the test is multiple choice, most of the strategies apply to that. Really, the only one, I didn't mention it in episode 2, but making up your own values is possible for grid-in or open-ended questions, but obviously plugging in the answer choices is not possible because there are no answer choices, right? So, but this one actually works out quite well, right? It's a system, and they're asking us for an expression. So what we need to do is, well, let's just talk about the school way. We just went through the whole school way a couple times. The school way would have us eliminating one of these variables, all right? Well, to do that, 2x and 3x, I need to multiply the first equation by 3 and the second equation by 2. Then that would allow me to eliminate the x's. I would solve for y, have my y, plug it back into one of the equations, find x. Now I have my x, now I have my y. Plug it in here, do 5 times my x plus 5 times my y, and I would get my answer. But instead of doing all of that, all right, let's just look at it like this. Just add your equations together. 2x plus 3x is, 5x. 3y plus 2y is, 5y. 1200 plus 1300, 2500. We don't even have to do anything else. That is it. 5x plus 5y. What is the value of that? Well, that is 2,500. All right. That's all you got to do. All right, now to the closer problem. College Board Practice Test 9, Section 4, number 36. 3/4 x minus 1/2 y equals 12. Ax minus by equals 9. The system of equations above has no solutions. If a and b are constants, what is the value of a divided by b? All right, so this is like our type of problem earlier where we have constants and we're saying that the system has no solutions. All right. This is, again, not missing answer choices. This is another example of a grid-in. You will be able to figure out A over B using either method. Try the school way, try your friendly math tutor way, and compare them. Try to see which way is quicker in this case. All right? We will discover that in episode 6. All right? All right, now to today's takeaways. So today we talked about linear systems. There are 3 types of linear systems that you're going to see on the SAT. One is just a straightforward, here's a system, there's x and y, all the constants are there as numbers, and you're just going to use the school way. You're going to use most likely the elimination method or possibly the substitution method. The second type is going to be one more like our closer problem here, where there's going to be some constants in there that you're not going to know. 1 or 2 of them will be unknown. And it's going to have to do with no solutions or infinite solutions. And what you're going to do, your friendly math tutor way, is to find the slope of each and just set them equal to each other. Because the slopes of either parallel lines or in infinite solutions cases, the exact same line, their slopes are going to be equal, and it's going to be a nice, easy way. But it really helps if you can figure out the slope of a line that's in standard form, just knowing that it's negative a over b. That is nothing you have to memorize. You can hopefully visualize moving the a to the other side and making it negative, then dividing by the b to get the slope. If that's a problem for you, then what you would just do is the school way, where you would try to make the left side look the same and then kind of match them up and pick the value of the variable that will make it equal. All right, and then the last way is when they give you a linear system, more like the method, more like the first type. There's no constants missing or anything. The only thing that's not there, missing, or the variables are x and y. And in that case, what they're going to ask you for is some expression. They're not going to ask you for x or y. They're going to ask you for some expression. So the school way is going to take a lot longer to then find your variables and plug them into that expression. What's going to be best is to just add the equations together and then maybe do some slight manipulation by dividing or multiplying to get to the expression that they're asking for. All right. So this method is obviously pertains specifically to systems of equations, so it's only ever going to work for those. But as we saw earlier, it can work for there's some grid-in questions that are that have systems. So anytime you recognize a system, I want you to think about what we did today and approach it one of those, I guess, 3 different ways depending on the type of system that they're asking you. All right. So thanks for watching today. We appreciate all the views that we're getting and all the subscribers that we have. Please like us, subscribe if you haven't subscribed already, leave comments or questions or anything you have to say about these classes that these videos that we're making. Follow us on Instagram, Facebook, and Twitter. Until next time, your friendly math tutor is out. Ready. We're going to have to redo this problem. I think I made a mistake. All right, that's the end.